we're going to look at operations with functions. So the only thing you need to see on this screen, you really don't need to write anything down, is that it can be written two different ways. So this is saying if I've got one function plus another function, it can be written as the function of x plus the function of g. Okay? Or if it's a difference, if I'm subtracting two functions, it can be written as f of x minus g of x. Multiplying can be written f of x times g of x, and the quotient or division could be written f of x divided by g of x. I'm not even going to read these, okay, because I don't think there's a point to it until we get there. And then this one, it's actually putting a value in, finding g of 1, and then finding f, the function of x, when g is 1. So that's what we're doing today. Okay? All right, so let me get started with actually plugging some numbers in here, or substituting in some values and seeing what it looks like. So for instance, this first one, if I'm talking about f of x, every time I see f of x, I'm going to substitute it for 2x. So see how I have f of x in each one of these? So I've got 2x, 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 and 2x. The first one says we're going to add this function to this function. So I'm going to add on this one, subtract on this one, multiply on this one, and divide on this one. Now I'm going to change my color and say, okay, now it's saying I'm adding f of x, which I know is 2x. I'm going to add that to g of x, which I know is 3x plus 4. So I have 3x plus 4. This is the quantity, 3x plus 4. The quantity, 3x plus 4. Why am I writing the quantity? That, because there's a negative sign there. This doesn't really apply, right, because we're just adding them together. This one, because I'm going to multiply 2x not only by 3x, but also by 4. And this one, because let's give x a value. 1. Okay. So 2 times 1 is 2, divided by 7, right? 1 is not a good one because it just makes it look the same. What about 2? 2 times 2 is 4 over 10, which is 2/5. Is that what I've gotten if I just canceled the x's like that? See why you can't do that? That's exactly why you can't do that. Yes. I'm just plugging in a number to prove why you can't, because I know students, and the first thing they want to do when they see this is, oh, there's x's there, I can cancel them. Right? You can't do that. When can you cancel x's? If they're factors. Because what you're really canceling is, you're canceling out a 1. Right? But you can't do that unless they're factors. These are not factors of each other. This is saying 2x, 2 times, or 2 x's, and this is saying 3 x's with 4 added to them. Okay? So this is a quantity, so don't make that mistake. All right, second thing we need to talk about is you can never have what in a denominator? Not a negative. You can't have a 0 in the denominator, right? So whatever 3x plus 4 equals, we know it can't be equal to 0. Therefore, x can't be equal to negative 4 over 3. Because if I put 4 over 3 in here, I'm going to get negative 4 plus 4 is 0. So to get that number, I did that really fast in my head, but I would just solve, right? And you get 3x equals negative 4, and then x equals negative 4/3. In the same instance, it says down here, x is raised to a fractional power with an even denominator. Okay, so x to the 1/2. X has to be equal to 0. Sorry, greater than 0. Because if you remember, let's look at this. What are the sides of this box? If the area is x squared, what are the sides? X times x. So what if I had just x? Or, good job, square root of x times square root of x, or, like Evan said, x to the 1/2 times x to the 1/2. So this is the same as this. But when this happens, why does x need to be greater than 0? Because if it was negative, it would be imaginary, and you can't have that in the denominator. Make sense? Okay, that's a lot to take in, right? So write that down. I don't know if you really need to write this down. I think we just need to do problems. You just need to do it. Okay, let's just do it. So this will be online for you. You can go ahead and print it out if you want to. All right, so here's our first one. So I've got 4 instances here. F plus g, f times g, f minus g, and f divided by g. So the first thing I'm going to do when I look at this is say, well, really what this is saying is the function of f of x plus g of x. This one is saying f of x times g of x. This one is saying f of x minus g of x. And this one is f of x divided by g of x. I'm going to start with blue. F of x is 8x minus 3. I don't think we really need a pencil scale. I think just writing it. I'm not giving you any pieces of information that are vital. We're just basically going through the motions on this stuff. So, 8x minus 3, I'm substituting now, correct? And I'm going to write them all at the same time, just because it's easier. 8x minus 3, I need an 8x minus 3 over here. I need an 8x minus 3 here, and an 8x minus 3 here, and that's a quantity. The first one, what am I supposed to do with this function? Add. The second one, well, multiply. The third one, so that makes this a quantity, right? The third one, subtract. I better make it a quantity so I don't lose that subtraction sign, right? And the last one, I'm dividing. This one is in the green. I just have to write it everywhere I need to, right? 4x plus 5, 4x plus 5, 4x plus 5, and the quantity 4x plus 5. Give you guys a second to write. Okay, so this one is 8 x's and 4 x's makes 12 x's plus 2. This one, I'm going to FOIL it in my head. Are you guys okay? 32x squared, 40x minus 12x is 28x minus 15. This one is 8x minus 4x is 4x negative 8. And this one is just, you can't simplify it any more than that, except we need to say that x cannot be what? Negative 5 over 4. Yes? Why negative 5 over 4? Because if I plug in negative 5 over 4, that will become negative 5, and negative 5 plus 5 is 0. Make it equal to 0. Take this right here, the denominator, set it equal to 0 and say it can't be that. When you solve, you will get x equals negative 5 over 4. All right, so we've already written that down. So here's the newer stuff. So composition of functions. Another operation that can be performed with two functions is called composition. Composition is when you take the output of one function and plug it into your second function. If you plug in a number for x, you will get a number as your answer. Okay, So I'll equate this to, here's my analogy. I'm going to make 2 batches of my kids' favorite cookies for Thanksgiving, okay? But instead of using sugar, I'm going to use Splenda. So, guys, so would I make the recipe first and then take out the sugar and put in the Splenda? No. First, I would go in and substitute in the Splenda for the sugar and then make the recipe, right? So same scenario, okay? So I've got a function when g is a function of 1. So the way we're going to do this is I'm going to start with, well, what is g of 1? I'm going to start with the inside first. What is g of 1? Let's find out. Well, g of x equals x plus 4. So what is g of 1? 1 plus 4, which equals 5. So that's the inside of my function, right? There's the Splenda, 5. So g of 1 is 5, correct? We all agree?
True.
So now I need to find f of g of 1. Well, isn't g of 1 5?
Yes.
So I need to find f of 5. I'm just substituting. So f of 5, well, what's my function? F of x is 3x. So f of 5 is 3 times 5, which is 15. All right, I'm going to do one more. So I'm going to start with the inside of my function. So I'm going to begin with h of x is x squared minus 1. So h of negative 3 is negative 3 squared minus 1, which is 8. So now I need to find g of h of negative 3. Well, h of negative 3 is 8, so I need to find g of 8. Well, g of x is x plus 4. So I'm going to substitute everywhere I see an x, I'm going to substitute in 8, which is 12. So go ahead and write that down. Okay, so I don't think we need to do these. How much time do we have? Yeah, we have plenty of time. You guys try these. Okay, so let me unveil the process. Does anybody have questions on these? 5, 4, 3, 2, 1. So the first one I plugged in or substituted in 0 into my h function and got negative 1, and then negative 1 into my g function and I got 3. Substitute 5 in, get 15. Substitute 15 into h, get 224. Substitute 8 into h, got 63. Substitute 63 into f and got 189. Yes, sir. Brian, every time you ask me that in the middle of the period, what is my answer? There's more. Okay, so you remember that answer, okay? All right. Are we ready? Okay, so you can also complete a composition of functions without a specific value for x, meaning when you plug in an x into the first function, rather than plugging into a number, your final answer will be an expression in terms of x, rather than a numerical answer. So I'm going to go ahead and do the first one. Just pencils down, just pay attention. All right, so I'm going to say the function of, right? I've got f of x, but it's not x, it's g, and g of x. So we're going to start in the middle. Start in the middle, like last time. But I'm going to rewrite it. F of, what is g of x? And what's f? F is x plus 3. Right? So everywhere I see an x, I really need to put x squared plus 4. Equals x squared plus 4 plus 3, which is 7. All right, I'm going to do this one, and then you guys are going to do these two down here. This one is g of, what is f of x? X plus 3. What is my function for g? X squared plus 4. So everywhere I see an x, I'm going to put in x plus 3 and square it and then add 4. X plus 3 squared is x squared plus 6x plus 9. Because x plus 3 times x plus 3, I'm doing it in my head, the perfect square trinomial, right? So x squared plus 6x plus 13. We should have changed these. These should all be a different color, huh? Make them green. Questions? All right, copy that one down and do the next two down here. I really need it to be right about here. Is that good? You guys can see everything there? Good. So here are the other two. This one finds f of x. So f of x is x plus 3, so I'm working inside first, right? Then I've got to find, replace x with x plus 3. This one's a little more difficult. Yeah. Well, it's not asking you to completely two different things, right? What are these functions? Yes. And this would be 4x squared plus 4x squared plus 16. Yeah, if you want to, do this. It took me a long time to be able to just do it in my head. Are you guys ready? Moving on. Okay, here's the last one. Already, because I want you guys to work on this. Okay, so this one is saying I've got a composition. I'm going to find g of x which with respect to h. That's the way I like to say it. Many teachers say it many different ways. But this is the composition of g of h of x. I like to write it like this. G of h of x, which is exactly what we've already been doing. And h of g of x. Does that make sense? We're talking about a function of g with respect to h. So you've got to talk about h first, and then you can talk about g. So I don't think we need to do all of these. Let's just do two of them. Sound good? So if I were to do this one first, I would say g of, what is h of x? X plus 2. What is my g function? 2x. So everywhere I see an x, I'm going to substitute in x plus 2. Same thing as we were doing before, right? And the other way, h with respect to g would be h of, what's g of x? 2x. And what's my h function? X plus 2. Now everywhere I see an x, I'm going to substitute in 2x, which gets me 2x plus 2. See how you get something different? You guys try the second one. Okay, so here's the other one. Question? Okay. Okay, so h of g, right? Well, g is 5x, so I just substituted it in. Gotcha. Oh, I see what you're saying. Oh, you're saying that g of x, you put this answer in for this one. Oh, okay, gotcha. Do you see how it's different, Evan? Because this isn't really g of x. This is g of h of x is what this answer is right here. Any more questions? Okay, let's get started on, what did we learn today? Plug and check compositions. Okay, you guys, I need you to freeze. Okay, this is what, I don't spend this time doing it because sometimes it takes quite a bit of thought to come up with these. Okay, and then you guys aren't paying attention, you're just putting your stuff away. All right, how does composition of functions relate to what we already know about functions? What are we doing? What about today is the same as what you already know how to do? No, you're just substituting in for x, right? Just getting a little more complicated. How would you explain this one right here? Okay, I hear a lot of things. I hear with respect, I hear you work in to out, right? We're talking about a function after this one occurs, right? So h of x occurs first, then we use that value for g of x. Okay, on your assignment sheet, what would be a real-life example of composition of functions? So we've come up with a few of them during the lesson. What did we come up with? Cookies with Splenda, the dolls, the Russian dolls that they have an inside to them. What else? A Hershey's Kiss, right? With the inside. Inside of a Hershey's Kiss. There's a, you know, the one that, like the Hershey's Kiss with almonds. So good. All right, guys. I want you to get started on your homework. Everybody needs to be working for the next 10 minutes. Go.